Now it's Claudia's turn. She is traveling some distance from home and some distance back to home. We've labeled the sections as A, B, C, D, E, and F. And the first question is asking, what was Claudia's average velocity on the time interval? So basically, how far did she end up traveling away from home divided by the length of time it took her to get there? That's the same question we had here, not worded that way. What's his average velocity from 0 to 2? How far was he away from home divided by how long it took him to get there? That's what it really is. 400 divided by the 2 minutes. Okay, well, this is kind of a trick question. What's Claudia's average velocity? 0. 0 what? Well, 0 meters per second. We're dealing with meters in this case. How do I know it's 0? Well, here's the deal. In 100 seconds, how far away from home was she? 0. She started at home, she ended at home. Lots of traveling in between. But the question, average velocity, is a question of saying, how far from home are you divided by how long it took you to get there. So the computation is this: 0 meters divided by 100 seconds. 0. There you go. So I want to know Claudia's velocity at these time intervals, at these specific points. Now we get into a little more specificity of what the slope represents, and we're dealing with the slope at a point, okay? So I want to know the slope at a point, and we can make arguments. Does the slope exist at a point, and can change occur at an instant? Slope is rate of change, right? So when I talk about the slope at a point, yes, it can. But computing it is not easy. I'm pointing at no, it can't. Can change occur at an instant? No. At the smallest fraction of a second, like an infinitely small fraction of a second, everything is frozen. It's still for that infinitely small fraction of a second. But we can talk about the velocity at that point, the rate of change at that moment, by looking at what happens around it. And I'm using these vague terms as we dig into some bigger concepts in the future. Trust me on this. Claudia's velocity at 10 seconds. At 10 seconds, this is what she's doing. Her velocity is represented by this slope. What is her rate of change for this interval? Because 10 is in this interval. And she travels, let's see, 25 meters in 15 seconds. So 25 meters in 15 seconds. That's going to be, oh my goodness, why am I struggling with that? It's 5/3 is what, yeah, 5/3. It is 1 2/3 meters per second. Okay, notice it's positive, and here's the reason why. The slope is positive. So at 20 seconds, what's her velocity? Well, 0. 0 meters per second. She's standing still. She's not traveling further from home or closer to home. 40 seconds is here, and 40 seconds is on this interval. And this interval has a slope of, well, I would rise 5 and run 10. I could do the whole interval if I wanted to, but just picking 2 points and finding the slope is sufficient. So rise 5, run 10. That's a slope of, well, 5/10. That would be 1/2 meter per second. 62 seconds. So around in here, that's the section called D. That goes down 4 and over 1. So it really goes down 5, 10, 15, 20 and over 5. And so it's -4 meters per second. She's traveling pretty fast on that time interval. And this one is 70 seconds, 0. And 95 seconds. Okay, first of all, it's positive, negative, because she's traveling towards home. So it's going to be negative something, and it's -2 over 1. So -2 meters per second. Okay, during which interval was Claudia traveling the fastest? So which of these numbers has not, which is not the biggest, but which has the highest magnitude? Which has the highest magnitude? Well, 4. So it would be the interval that is represented by this 4, which was at 62 seconds, which is section D. We can answer it as section D if you want to just talk about the section. But if I'm talking about an actual time interval, then I could say Claudia was traveling. She was running with the ball, wasn't dribbling. Traveling, that is a joke, the fastest for the time interval, and we're going to go from here to here, which would be 60 to 65. So 60 to 65. I'll put seconds on that.